Happy STEM Friday! Did you guys know that the Earth's outer layer, also called the crust, is made up of these large moving pieces called plates? It's almost like a big jigsaw puzzle. Now these plates, there's about 20 of them, and all of Earth's land and water sits on these plates. The plates are made of solid rock and they are moving very, very slowly. Now, what happens, do you think, when two plates bump into each other or slide against each other? What do you think happens? That's right, an earthquake. Now, most of the time, quakes are so small that humans can't feel them, but every once in a while, they will be so powerful that you can feel them 100 miles away, and they can do some serious damage. Today I'm going to read a book that will teach us more about earthquakes, and at the end, I'll let you know what your STEM challenge is. Alright? Let's get started. Exploring earthquakes, seismologists at work. What is an earthquake? An earthquake happens when parts of Earth shake. Seismic waves cause this shaking. These waves start deep inside Earth. Quakes can occur anywhere, but most happen at fault lines. These are places where pieces of Earth's crust fit together. Sometimes these pieces slip past one another, and this causes a quake. Who studies earthquakes? Seismologists are scientists. They study earthquakes. They teach earthquake safety. Learning how quakes work saves many lives. Earth has 500,000 detectable quakes per year. Some are too small to be felt by humans. Others cause great harm. They topple buildings and they cause tsunamis. Tsunami waves can reach 100 feet or 30.5 meters high. Some seismologists do field surveys. They study the land and use equipment to measure seismic activity. Meet a seismologist. Charles Francis Richter. Charles Francis Richter was a seismologist. He was born in Ohio, but he spent most of his life in California. He became interested in earthquakes in college. Richter kept studying earthquakes after he finished school. At the time, scientists measured quakes using the Mercalli scale. It measured earthquake damage, but it did not measure earthquake power. Richter went to college at Stanford University in California. He studied physics at the California Institute of Technology after graduating. Then he taught about quakes. The Richter scale. Richter created a new scale. He worked with seismologist Belo Gutenberg. They invented the Richter scale in 1935. The scale measures the strength of seismic waves. A higher number means a more powerful quake. The largest known quakes were 8.9 on the Richter scale. Charles Francis Richter. Born April 26, 1900, near Hamilton, Ohio. Married Lillian Brand, July 19, 1928. Children, none. Died September 30th, 1985 in Pasadena, California. Measuring quakes. Scientists have tools to study quakes as they occur. They use these tools in areas where quakes are common. Machines record a quake's seismic waves. Scientists study these waves, and they figure out where the quake began. This is the epicenter. Sometimes a small quake means a larger one is coming. Knowing a quake's location can help scientists predict future quakes. This picture is a seismograph recording waves. Seismologists use computers and special programs to interpret data from instruments in the field, such as seismographs. After the shaking, tools exist to study quakes as they happen, but most study occurs after the events. Seismologists study a quake's damage, and they learn about the area's rock and soil. Waves move slower through some kinds of rock. This builds energy. It can cause more damage. Scientists ask people what the quake felt like. This gives scientists an idea of how strong the quake was. Shaking is more powerful in sandy soil. This can turn sand into liquid. Roads and buildings can sink or collapse. Predicting quakes. Scientists cannot predict earthquakes, but they can look for clues. These clues tell when a quake might be coming. Scientists study past quakes. This shows how often quakes occur in an area. Scientists also look at earthquake damage. This helps them tell people how to stay safe. Nature also gives clues about quakes. Common toads can sense quakes. They leave ponds and go to safety days before a quake. In 2016, an earthquake destroyed much of the historic city of Amatrice in Italy. Sad, huh? It's a lot of damage. Tools of discovery. A seismologist's toolkit. A seismograph. This tool records seismic waves. It draws lines. The size of the lines tell how strong the quake was. GPS. GPS measures the distance between fault locations. Scientists see if these distances change. Seismologists use many tools to measure and record quakes. Like the tiltmeter. This tool measures vertical ground movement. It tells how much the ground rises or falls. The strain meter. This measures changes in Earth's crust. It can tell if the crust is under stress. Quake safety. There is no way to stop an earthquake. But scientists teach people to stay safe during one. Seismologists teach engineers how to make buildings stronger. Strong buildings do better in a quake. They absorb the shaking. Future buildings may even have sensors. These could help a building withstand the force of a quake. Some engineers construct buildings with strong steel frames to withstand earthquakes. Now I'm going to show you the book's glossary. So if there were any words in there that you didn't know, it's okay, because you can just pause the video here and look at the glossary. Let's go back to that page about engineers. It says here that scientists, more specifically seismologists, and engineers are working together to build strong buildings that can withstand earthquakes. And that is what I want you to think about today. I want you to design and build a structure that can withstand an earthquake, which means can stay standing during and after an earthquake. You can use any materials that you have in your design, and you can test your structure by putting it on a table and shaking the table to simulate an earthquake. If the structure falls down, that's okay. Engineers know that they should learn from their mistakes, and they expect that they're going to have to go back and adjust their designs again and again until something works. So, a few words of advice for this project. Please, please, please ask an adult before you use any materials. This is a very important rule. Make sure you have permission. Also, stay safe, and as always, have fun with it. And who knows, maybe your invention will lead to innovations that can save lives. All right, bye.